All right. So today I want to build an arg parser, like command line arguments parser, because I feel like that would be fun. There are already libraries that do this in C, but I think it'd be good exercise to build my own. In preparation for this, I have sort of taken my integer hash set thing, integer hash set thing that I wrote before for the regex engine, and I have modified it to make a string hashing hash table. So instead of a set, it's a hash table. So key value pairs. I basically took this article from CP algorithms, and the main thing I took from them is this formula, the hashing formula. Um, but yeah, polynomial rolling hash function. You take each character and multiply it by some prime to the power of its index, and then take the sum of that and mod the whole thing and put it all in the world of mod m, where m is some big number that they say should be prime as well, maybe. So yeah, that's all this is. I have so the main change. So yeah, like I said, I took my integer hash set. Only real changes were that hash function, this one, which no, not this one. Sorry, where is it? This guy, the string hash, which uses that formula. Um, it uses the fast exponentiation algorithm thingy, something that I've sort of picked up from leak coding. But yeah, that's that one. That yeah, it should be like that. And then the only other real difference was because it's a hash table now, not just hash set for every key. There is also a value. In this use case of an arg parser, I'm assuming my keys are going to be strings, and my values are going to be strings as well, I think. But I've made the void star to make it a bit more generic. But the keys are strings, char stars. Um, Anything else I need to know? And then the only other thing was I used string compare to compare two strings rather than the equal sign, which is what was in the integer hash set. It's a bit more freeing at times because I make the assumption that the value. I make this assumption that the value, so assumes the value is on the heap. I I've kind of So my freeing function, for example. Wait, did this not change? Wait, I swear I changes. Okay. I thought this was gonna. I thought this was supposed to say. Maybe I didn't do it, but I thought this was meant to say free h access the hash table, the actual array, free the value first, and then free the actual item. So h is the overall structure. H is I need the structure. H is the overall structure, but then similar to the hash set from before, there's a hash table which is an array of pointers that for items, where an item consists of a key, a value, and whether it's a tombstone and the hash value. So, because I'm assuming the value is on the heap, I have to free that first, which I thought I had done, but I guess not. Do I do this anywhere? Free. Yeah, here I did it. Here I free the value before I free the actual item, but I forgot to do it in the actual free function. There you go. Okay. Anyway, hopefully, I don't know. I did like some mild dry run of like it's a few sort of tests, but whether it's correct or not is anyone's guess. Um, it seems to be okay, so hopefully it should be okay. Anyway, let us begin my arg parsing. So I'm planning on basically following the Python argparse library. Um, like there's not that's a very well written library with like a lot of documentation. Do I have? I thought I downloaded the. Maybe I didn't. Um, Yeah, so I'm basically planning on following this guy. There's not a whole lot to. There's depending on how much functionality you want, you could look at the entire thing. But obviously, I only really want an MVP, like a minimum viable product. So main goal is basically, yeah, build some kind of parser where you're able to add arguments. There are kind of two major types of arguments. There's positional arguments and there's sort of flags or options. Um, and we can go into details as we go, but the major idea is instead of like having to give standard input to a program in order to give it information, you can give command line arguments as you run the program, and that way you can give information that way. And I think this would be helpful for like other things that I kind of want to build, small things, nothing crazy, but like it would be nice for certain console apps that I want to build and see. So hopefully this will be useful. Yeah, so we can go through my little plan. So my general structure is, yeah, to provide a layout for command line arguments. When a user needs to first give what command line arguments a program should expect to see. So a user should specify positional arguments. So you think of like cat, for example, the cat program. Normally it takes in cat, and then you expect it to take in a file name generally. So that file name argument, command line argument, is a positional argument, right? It kind of, you expect the first argument to be positional. And that's those are positional arguments. Otherwise, you can also specify the flags or the options arguments as well, which is like the ones which have like a dash in front of them, either a single dash or like a double dash kind of thing. These can either be Boolean, like for example, WC-W. WC is the word count program. -W is a flag which specifies I want to count the number of words. If I was to do -L, that would indicate I want to count the number of lines. There maybe is -C, I think, for a number of characters, but yeah, you can also specify like WCL to mean like I want all three counts to show up. But for now, we'll just keep it as W. And so that's a Boolean flag because you don't give any more information than just putting the presence of the -W tells you how the functionality should work. It tells you that you want to count the number of words. There's no other information. That's a Boolean flag. Otherwise, you can have, I think they call it a named option or something. I forget exactly. Oops. Whatever. I don't remember what they call it. But it's, instead of having just a Boolean flag, you can have flags which have a like more information associated with it. So for example, in grep, you have the -- file option or flag, but that's not a Boolean flag. You have to then give the file name or path, I think, associated with that flag. And so in this case, when you do that for grep, it tells grep that instead of giving the regex pattern to grep like through the arguments, the regex pattern should be found in the file that is specified. Grep is basically a regex engine in itself, kind of thing. Anyway, but yeah, so bottom line is flags can either be Boolean flags, just specify them by themselves, no extra information, or can be flags that give more information afterwards, so like directly after it. And then I also just mentioned, I think I need to specify a type for the flag in terms of like, in this case, a file name is probably a string. But there might also be, there's certain flags, for example, where you want to specify a number, like dash, you put a dash and then you put like your flag and then you put like a number in front, number afterwards. So that tells you, it should be, an integer kind of thing. Because everything's going to be strings when you read it in, right? Everything's sort of a string because it's a char star array when you read in command line arguments. But what that information is actually supposed to represent might not be a string. So you should specify that. And then, yeah, from there, after you provide the general structure, command line arguments, you can imagine, will be given to the user's program. And then when the user sort of asks for those command line arguments to be passed using this library, we're going to go through each argument one by one. we assume the 0th argument, or the head argument, is the program name, right? When we run a program, we normally do like dot slash a dot out or whatever, right? We do like that is the command line argument at position 0. It's everything after that that is going to be, command line argument 1, command line argument 2. This is 0. This is index 0, then 1, then 2, and so on. So we can kind of ignore the 0th index because that's not really giving... That was just a way to run the program. That's not really giving any command... That's not really giving any extra information. So 0th one is just the program name. Then from there, we go through each other argument. If an argument starts with a double dash, that represents to a flag, right? If it's a Boolean flag, then we just need to know that, it should be set to true because it's present. If it's not a Boolean flag, then we know that the next argument over is going to be the value associated with that flag. Now, if it starts with a single dash and not a double dash, then same thing, right? It's the same idea, except I sort of quickly mentioned for Boolean flags of a single character, you can put like multiple in the same sort of group. So with a single dash in front, generally you expect these 4 characters to represent 4 different flags. I don't know if this is like strictly true. I haven't actually looked at like the rules of command line arguments, but I'm going to assume that's the case. And if it's not, then oh well. That's how I'm doing it. So if the rest for this argument, the rest of the characters in this argument represent one or more options, where each character represents one option. So if it's a single dash, we expect just single character options or flags. If one is a Boolean flag, if you're a Boolean flag, then you kind of expect all of them to be Boolean flags. All of them should be sort of either it's there or it's not kind of flags. If one is a value option, then there should only be one. Like if you're gonna give, instead of dash dash file, they might also say dash f to represent the same thing. In which case you need to give the file name, which is like the value associated with the flag. But I believe that means you can't then put other flags with this one because that guy is supposed to represent that. I'm not really sure, to be honest, but that's how I'll write it, is like, if you want to put a bunch of Boolean flags together, that's fine. But if you want to put a value flag, then you need to put that value flag alone and then put its value and then put the other flags, is how I'm planning on doing this. Otherwise, if it's a value option, yeah. So I'm really not that sure. I probably should do more research or whatever. Otherwise, if it's not a dash dash and it's not a dash, then we found a positional argument. That's how I'm defining it. I think that's how it's supposed to be defined. So we found the ith positional argument. Remember, from up here, the user of our library will specify the positional arguments in order. So we know what this argument is referring to from the template they gave over here. So we take its value, right? Because let's say the first positional argument is meant to be, like a file, like for cat, right? They're not going to... The argument itself won't have the word file name in it. It will just say, it might be like cat and then like example.txt. But we know that the very first positional argument is meant to refer to a file name. So as soon as we read this whole thing in, we know that this whole thing is for the file name, right? Because it's a positional thing. It's kind of like a function, how it takes in arguments and replaces, like for each parameter, it takes in an argument, and we know what we know that each argument lines up with each parameter, is what I'm trying to say. Anyway, so that's like the major plan, and then yeah, I'm making the assumption that positional arguments are mandatory. Like sometimes you can have optional things, but I don't know if that's I don't know. Like normally the flags are optional, but the positional ones are mandatory, I think. So that's kind of how I'm going to go with it. And yeah, my example used for my library is something like you initialize the parser, right? Then you might give a positional argument. You provide your parser, and then you give the file name, for example, as a positional argument, and then you give like s to represent it's a string type, right? So you're specifying the type using a character, and then you might say like parser num lines I. This is integer type, and these are both positional arguments because there's no dash dash anywhere, so we know they're positional. So they won't have any flags. It's just when you run the program, like let's say a.out, you will give a file name, example.txt, and you'll give a number like 3, and that we know that this is for the first positional argument, this one, and this is for the second argument, this one. So like without having to give any flags. And then you might want to add a flag. So instead of add argument, we might say add flag. It takes in a shorthand version -r and then a long version --read or read. It's a string type. Optional equals true. I don't know if I need this, but I think I will keep it. Like if it's optional, then if they don't give that information, then that's fine. But if it's not optional and it's mandatory, then we're in trouble, or they're in trouble. And then another Boolean flag. So yeah, I specified it's Boolean using this b, right? So here we said s, which tells us it's not a Boolean flag, it's a string, so they're gonna have to give extra information. But for this, it's a Boolean flag, so instead of having to give extra information, the presence of the -x is what tells you that the flag exists. And then args is basically, yeah, given the template, given the, this is our template, and given the command line arguments, right, argc, argv, we will get the actual values of the args. And I believe this will be a hash table where the keys are the arguments and the values are the values given by the user, but as strings, or more specifically as, I think it's going to be structs actually, because I need to specify the type information. So that's the general idea. Args will be a hash table with strings as keys, that's what we said. And then the value of the hash table will be this struct arg. I already said this. So the struct argument will be a value, which is the string, and then the type, which is the char, right? Either it's going to be I, S, F, D, or B for int, string, float, double, or boolean. That way I can kind of, even if everything's a string, I can sort of figure out how to parse it as the desired type. So that's the overarching plan. Is it a good plan? Not really. Is it well... Oops, didn't know that would happen. Is it well researched? Absolutely not. But here we are. Building something that I really don't need to build. All right, so how will I start this? I will start by thinking about my structs. This is wrong. I'll move this along. Oh, I didn't mean to do that. All right, move this over here. All right, so what are we doing? Let me just want to start fresh. Minor. I shouldn't add it all actually. Minor edits, including correcting free in string hashing .c. All right, it's fine. All right. Okay, fantastic. So we have that. I'm probably gonna need if I just include my string hashing, that should be good, because that includes a lot of the libraries already, so I should be okay. I do need to put guards though. I forgot. I'll remember after. Okay, so yeah, struct. What did I say? Struct. So an argument is going to look like a char star value, the string version of the value, and a type. And in fact, I think I will make an enum called types, or type, arg type, we'll call it. And it's either going to be B for Boolean. I guess, do I have to? Yeah, it's fine to make characters, right? B for boolean, S for string, I for int, F for float, D for double. Fair? And then we can say like type def enum, enum arg type becomes just arg type. And then we can be like bing, bong, bing, bong. Okay, so we have that and we have that. Should I also be like, I feel like I don't normally do this, but char star, we just call it string? Like, is that better? We'll see, we'll try it. Anyway, so we have these different characters, that's cool, and we have some type defs and we have the argument. Now we need the actual hash table, don't we? So the hash table will consist of all this stuff, and each hash table item will consist of a key, which is the argument string, the value, which will be this struct, hash number, and whether it's a tombstone. Okay, this is making some sense, I think. I just realized I think I have to give, since it's void star value, I think I need to ask the user to give a function to free the value itself, because in this case I might get away with it, but anyway, it's fine. It's not a big deal. What am I thinking? Okay, so I need to make an init function. I should probably make a parser, struct parser. Normally I put underscores. Alright. Arg parser. This is like the main, this is the main guy, main event. So the arg parser is gonna have a hash table of right? It's gonna have that. It's gonna have a hash table, and that might be it, to be honest. Does it have anything else? I don't know. Maybe not. Okay. Let's just leave it like that for now, I guess. Okay, so if I want to return arg parser init, we're going to have to make the hash table. So arg parser is equal to malloc size of arg parser. Very good. Then we're going to have to say parser. Oh, what? This is wrong. Am I tripping out right now? What? String hash table init, and then return parser. Why do I wait? Why is this not working? Why can't I use arg parser? I typed def, didn't I? This feels weird. Is it working now? I tripping out? I'm just gonna leave it. I think I should be fine, no? I don't really know. Anyway, so we initialize, and then we have to add an argument. So I think if I say void, I should be okay. Arg parser add argument given the arg parser given string argument and given arg type type. So what I have to do, I have to parser. No, something really. Why is my intelligence? Okay, fine. Struct arg parser pointer. Did I even forget? Oh, I forgot the struct. That's why. That makes sense. Okay, now that should be out for a second. Okay. HT. I need to string hash table add, given the hash table, the address of the pointer to the hash table. So parser this guy's address, and given the key, which is the argument, and given the value, which is actually something else. I need to make an argument. So argument star malloc. Did I do this? I didn't type this. Okay. So argument arg is equal to malloc size of argument. Arg type is equal to type. Arg value wait, I don't have to do this yet, do I? No, I don't. I'm being dumb. For now, I think I can make this null. The idea being I think I can make this null because the idea is the value's not given yet. I'm just adding the argument. I'm not actually adding the value. So I'm being silly. So add the argument. Okay, fantastic. Maybe that's good then. And then add the flag. Void arg parser add flag. And then yeah, string short. String. What's wrong with that? Invalid combination of. What? Am I dumb? What's the difference between invalid combination? This might be double pointed, to be honest, or something. Invalid combination of type specifiers. Invalid combination of type specifiers. Huh. Hang on, let me just check one more thing. Long type arg type and boolean optional. Sorry, boolean. Bool. Is it because I don't have braces? But invalid combination. Ah. Does it think... What? I'm nervous that it thinks that char is being replaced with dot, like star string, which doesn't make sense, right? Should I just make it char star? I'll figure it out later. Oh, it's still bad. Still doesn't like it. Expected a bracket. What have I done? I feel like I've done something really silly, but I can't see what I would have done. Expected a bracket. You got a bracket eventually. Hang on, let me get rid of this whole thing. Is it an error in here? Okay. Let me just, I don't know. I can't tell if it's VS Code being weird or if I'm just blind. I can't actually tell. Okay, let me try this again. Hang on. Parser. Pointer. Parser. Then char star short. We're fine? No, we're not fine. We're genuinely upset. Why? Why do you expect the thing? It's a function. Like what? I'm actually like so confused right now. Char star long. You expected a bracket. What, here? You expected a bracket? What? Is this like a keyword or something? What? Why is it this function that's like causing problems? Alright, I'm just gonna type how I think is right, and then if it wants to complain, we'll figure it out. Arg type, and then boolean, not boolean, bool optional. Okay, so see, the thing is, right, if someone gives the dash option versus the dash dash option, they need to refer to the same thing. So I kind of want, I like need another hash table. I feel like I need two. Like I need a string hash table, long to short kind of thing. If that makes sense. Like I need a way of translating between what is what the long version of an argument is and what the short version of an argument is. So maybe I need both. And then so I need like two hash tables. I don't know, maybe that's dumb, but I feel like I need that. So for a flag, but what if someone gives a short flag and you have to look up what the long flag is? So I need two more hash tables? For a two-way translation? Surely not. Can I just check one thing? Can a flag option be with one dash be more than one character long? Yeah, wait, what? Yeah. Oh. Yeah, okay. I don't know if I'm making any sense right now, but basically translate between a long flag and a short flag. But what if you give, if a user gives the short flag, Yeah, so I need to make sure the structure is accurate, but there's two sort of places where, like, there's two ways you can give a particular argument: the short version or the long version, one dash or two dashes. So I need to, if they're only going to give one of the two options, so I need to make sure that both of them are kind of set to true or set to the value or whatever. Hmm. I could make a third hash table, but I just feel like we're starting to get a bit ridiculous. String hash table, long to short. I still don't really understand what's happening here. Oh, short might be a thing. Short's a thing, isn't it? Short's an actual, but so is long. Maybe long will also complain afterwards. Okay, I understand what's happened. Short is an actual type. Yeah, it's a keyword. Ha, it took a minute. No, that makes sense. Short option. Long, yeah. Okay, I'll change this back to string then, because that wasn't the issue after all. Type def char star becomes string. So wherever I see a char star, I can replace it with string 4 times, not that one. Okay, should be good now. No? Wait, what? What did I do? Oh, I must have messed up the comma or something. Okay. It's a bit of a long line there. Parser, the options, the type, and whether it's Boolean. Okay, back to thinking about this. Yes, true. I'll have a third hash table. Am I giving the option for either of these things to be null? Maybe, I guess, right? Like, if short option is null, that means you only want to give the long option version, and if long option is null, you only want to give the short option version. That could be a thing. If short option and long option, then so string hash table add, given the passes long to short, given a key, given the key, which is I guess the short option, right? And given the value, which would be the long option. Although I did say that I assume the values are on the heap, so I have to stir it up or what? Is that a good idea or was that dumb? Because when I free all this stuff, it's going to try free the value, but it won't try free this one because I assumed that this would be on the stack because the command line arguments I think are on the stack. So there's no need to free them. We'll do it like that, whatever. Long option, and then we'll stir up the short option to move that up on the stack. So that gives us our translation. And then if short option, then we have to string hash table add the short option, and then if long option, we have to string hash table add the long option. Would be my thinking about all that. So we can add a flag, and then finally we have to pass things. Wait, I didn't even use the optional thing. So maybe I do need to give an argument straight away. Boolean bool optional. Yeah, because I didn't use the type information as well, right? Like, I didn't use this at all. Oh, yeah, okay, so I need to give the thing. Okay, hang on. So it's not null at all. Arg value at the moment is null. We don't know the value yet, but arg optional is equal to, I'm going to say false. So I'm saying these positional arguments are going to be false. Like, they need to be there, sorry. And the type is given as type. No, not that. The type is given as type. And we pass in the argument. Maybe I shouldn't call it argument here. I should call it like arg name or something. And then the actual argument, like spot, is that. Hopefully that works. And then same kind of vibe over here. Oops. The only difference is I should probably say something like if not short option and also not long option, then we're in trouble. I'll make like a printf type thing. When using arg parser add flag, at least one of short option and long option should be non-null. And I'll just say this is part of the arg parser, and this is the arg parser add flag function. Okay, otherwise this should all be safe, and then value is null. This is given by optional, and this is given as that. And instead of null, we can say arg, and arg again, so it's the same address twice, and yeah. Okay, that should be fine, I think. Maybe I do something similar here. If arg name, if not arg name, if it's null, then f printf. So this is arg parser add argument. Arg name cannot be null, I think. I don't know why you would use null there, but yeah. Trying to protect the user as much as we can. Kind of. Okay, so we do all this. So what's the error for? What? Did I miss a semicolon or something? Too few arguments in the function call. Oh, I forgot the standard error part. Okay, so we have a way of adding arguments and stuff, which is cool. Then we have to actually pass the arguments. So this is the last function. So this will get us our args thingy. I guess it won't actually return anything because the information is going to be stored in here, I think. You know, like hash table or whatever. And I need a get function as well. Get from the parser. From the parser, you want to get some particular argument, some particular option, I guess. Something like that. So, yeah. Void arg parser pass. So given the parser, given yeah, that should be it, right? And then I need to also get the argc, the argv, argc string argv array. All right, here we go. So argc tells you the number of arguments present in the command line arguments, and we know we're ignoring index 0. So for int I equals 1, I less than argc, skipping I equals 0, as this refers to the program name. Okay, so we do all that, and we say, if argv I, yes, so we access the particular string. If that guy at index 0 is equal to the, no, that wouldn't make sense, right? It wouldn't make sense for it to be empty, otherwise it wouldn't show up. If it's one char, if the first character is a dash, yeah, I think this is fine. And the second, because I expect, I don't know if this is like, this might not be the best way of writing this, but whatever. If the first two, because like, it's definitely going to be at least one character, which means the size of the string itself is going to be 2, because it will be at least one character and then like the null terminator. So I think it's safe to access the first two kind of characters there. If they're both dashes, then then option, how do I do this properly? Then here's what I'll do. String flag is equal to argv at I. In fact, the way I've written it, I think I can do it like this. If it's a dash, then I know it's a flag. And then I can be like, boolean long flag is equal to whether or not. Okay, here's what I'll do actually. Here's what I'll do. If argv at I1 is the null terminator, that's kind of dodgy, I think. I don't really know. Printf, I'll just say argparser does not support as an argument. There might be reasons why you do this, I just don't know what they are, and I'll take the blame, right? But you should have, you know, one more character at least. argv I1 equaling another character tells us if it's long. Boolean is long is true if the next character is also a dash. And something like if is long and argv I2 is the null terminator, then same kind of vibes. Don't know if it's necessary, but what can we do? So, I just realized I don't keep track of the positional arguments at all. Like, I don't remember which one is which. That's funny. Okay. If I want to keep track of positional arguments, do I need another hash table? Oh no. Yeah, mapping a string to an index kind of thing. String to a position. This is getting a bit ridiculous. Boolean is long equals argv I1 equals dash. If the next thing is that, then I'm going to say. See, I know that this is bad of me because I know, for example, the leaks program takes in dash dash as a kind of like a separator almost kind of argument. But anyway, if argv I0 is equal to dash, okay. I'm going to say argument arg is equal to string hash table get given the hash table, so given the parsers I forgot to put a pointer or something. Is that why? Yeah. The parsers hash table. So given the hash table, I have to give the key, which is argv at I. And I have to cast it. Oops, I missed. Is that fair game? String, I give the hash table and I give the argument as a key. If argument type is equal to Boolean, I really shouldn't call it B. I should say the whole thing. If it's Boolean, then that's it. Well, actually, first I should check. If arg is null, fprintf standard error argument argument blah is not valid or something. So given the argv at I think. Now, if it's not null, if it's bool, if it's a Boolean type, then that's the whole thing. I don't think I have to do anything else because or rather, maybe I just have to say the value which is null it's a string the value that's associated with it. Maybe I can just make like malloc true or something. You know, just give it something so that. Not Malik, sorry, stood up. I think I'm gonna have memory leaks though, because again, the string hash table I think will free this entire thing, but won't free anything in here. Yeah. So if it's that, then do that. Otherwise, arg value is equal to arg v I plus 1. I have to check if that indexing is okay. But yeah, arg plus 1. Maybe I can do an increase I by 1 immediately. Can I do plus plus I? Does that work? Maybe try that later. Arg v at I. If arg c is now, if I is now an invalid index, if I is now an invalid index, then f printf argument requires a value arg v at I minus 1, because I've increased I now. Anyway, arg at value is equal to I, arg v at I, but stood up, maybe, just so that it's also on the heap, and then everything's on the heap, or something. Maybe I can, like, if I make this like a static thing, is that a thing? Like, static global, like static string true equals, I can't use true. True literal equals true. Like, can I do that? And then, like, I can't change it or anything or something. And then I don't have, maybe everything can stay on the stack. Because, like, anything in argv will be on the stack basically until the end. Like, argv is a static. Like, it exists until the program ends. The lifetime of the argv is the same as the lifetime of the program. So, I don't know. But, damn, I've been going for like an hour. I have no idea what I'm doing. Okay, anyway, I think this is fine, maybe? Whatever, I'll keep this like this for now. I'll deal with the memory leak as it comes. So yeah, if it's a dash, then I know it's one of those flags. The flag, did I even use this variable? Absolutely not. As in, I use it, but like, I use the word flag up there, but I don't use it anywhere down here. So, yeah, if the next guy is just if it's a single character, then I'm a bit like, If the boolean is long, is equal to argv. If is long argv, if, yeah, so no dash dash by itself. And then get the argument. If it's null, then that. If it's a boolean type, then just set it to true, set its value to be the string true. Otherwise, whatever came after this dash should be but I just realized I've assumed that for the boolean version, I've assumed there's only one character, didn't I? Oh yeah, wait, because I've given the argv. I think I need to split it into multiple cases. I think I have to, because if it's a single dash, and it really is a single dash, I guess I have kind of split it into multiple cases because I have the long thing, but I didn't really use it. All right, I might do this again. All right, done some slight modification. Not, well, a bit more than slight, but just rewritten it in a way that I think is a bit better. Nothing crazy, but just basically I've split the cases. So yeah, we're iterating through each argument. We're checking, is it a double dash, which I think is a safe operation to do in this context, because I'm pretty sure the length of a string in the command line arguments will be at least one character, because white space isn't really, like an argument isn't really counted unless there's some non-white space involved. So I think that'll be at least one character, which means the size of the string will be at least 2 because of that null terminator. So I think I can access index 0 and index 1 without too much fuss. So we can check if they're both equal to dashes, then we know it in like a long option kind of version. In which case, we do we make sure that it's not just a double dash, because if it is, then I don't know what to do about that. So I just throw an error. Otherwise, I have this helper, which basically, given the particular argument, the long argument, dash dash argument, it also takes in the argc, argv, and the index we're up to in the argv. Given all that, we should be able to add the value corresponding to that flag. So if I look at add argument, maybe I should call it flag. Add flag value, because it's specific for flag, so I'm using it. Okay. Anyway, so what this does is it gets the from a particular key, in this case, the starting the argument we're up to, given that key, it gets the corresponding argument struct. If it's null, which it can be, if this doesn't exist, if the key is invalid, then it returns null, just returns null. If the type of this argument is otherwise Boolean, then I know that the presence of this flag is all that is necessary. So I just give the value of true. Otherwise, I know that the next element in the argv is the sort of value associated with this flag. So I make sure that the index is fine. That's why I have to give in the index. I check the index is fine. If it's fine, then I say argv's value is taking the next argv. The next arg value is the next argv argument. And then I do that. And then I return the arg. Just for some error checking, because especially up here, if I run this whole thing, and then if it returns null, then I know that the argument given is invalid, I think. So that's the case. And then, yeah, in this case, we're in the long version. So now we have to look at the short version using the long to short hash table. So I should hopefully get a short version of like the dash with a single character, if it exists. And then I give all this. I might also say if not key, because it's possible that this is null already. If not key, then return null. I'll just say that as well. But that's okay if it's if at this point if it's null, it's fine, because so long as the top guy is good. And then yeah, here if the type is not bool, that means I've already used the next argument, right, as the value of this argument. So I should move I once, and then when the for loop runs, it will run again. the I value will increment twice, basically here, and then one over here as well. Else if, I need to change this, but else if it's just a single dash, right, but this guy was not, if it's not a double dash, if it's a single dash, again, check, is it just a single dash by itself? If it is, I don't know how to handle that, so make an error. Otherwise, you know what I have to do? So I have to do a for loop. For, and this time I won't use string because I'm not referring to the whole string. I'm looking at a particular character. char star c equals argv I1. Looking at that very first character, skipping the little dash, c should not be the null terminator plus plus c. And for each of these each character in here, I think I should run all this. I think that's the only difference. Or maybe, actually, if argv I2 is equal to null, that means I only have a single character. In which case, I think I can just run. I think I can run this, which is basically doing the same thing as what the long version was doing. It adds the flag value given the particular thing. In this case, though, I get the long version using the short to long hash table, and then adds the flag value there. And if the type is not bool, I increment I. Else, if there's multiple of these short flags involved, then I'm making the assumption that they all should be Boolean. Maybe that's not fair. I don't actually know. Maybe I shouldn't do it like this. Is there a better way? I just don't get how I'm supposed to have that functionality of like dash and then like multiple characters, but they each represent a separate flag, unless I enforce it as like as a single-minded rule. So I can't use argv here because I only want one character and there's multiple characters. String concatenation. Given that and given string flag is equal to dash followed by argv followed by the character c followed by the new line Why is that in blue? Okay, sure. String flag is equal to, oh, I can't do that twice. String string heap flag is equal to stirred up flag or something. And then I give the heap flag over here. If argument type is not Boolean, I'm just going to throw an error and say fprintf standard error. Argpass assumes arguments of the form dash abc consists of only Boolean flags, is what I'm trying to get at. Exit 1. So it's gonna take that particular character thing. It's gonna take that very particular guy. It's going to add the flag value, and if that argument that I get from adding the flag value, if it's not Boolean, then I'm going to throw a tantrum. Oh, I should say if... Maybe I should have this guy first, actually. If it doesn't even exist because flag value return null, then that means there's a problem, otherwise that. And then long version is the short to long, but instead of argv, I'm going to use the heap flag. And then add the flag value long version, argc, argvi. And the arg type is not Boolean. But that should never happen because it should always be Boolean, is my thinking. So a bit convoluted, this function. I'm hoping to clean it up, but that's the general gist so far. If it's an option, if it's a flag. If it's dash dash, then I expect a single name, so I can use the entirety of the name, right? The entire argvi. But if it's a short, then either it's one character, in which case it's a flag, and it's a single option. It's a single option flag, and it can either be Boolean or it can be non-Boolean, and we just take the information as required. But if it's a bunch of single characters that follow the single dash, then I have to go through each individual character and figure out what option it refers to, and then set it to true. And it should be Boolean. If it's not Boolean, then I say that's a problem. Okay, now the big else, there's a lot of nesting. The big else is if it's a positional argument. If it's not a dash dash and it's not a dash, then I assume it's a positional argument. Now I need a way of mapping positional arguments. So what I have to do, I think, the way I can do this is have an integer that says number of positional arguments. When I init, I should say that. Whoops, did not mean to do that. When I init, I say number of position. Oops, I say parser num positional arguments equals 0. And then I need. I don't want to do this, but I think I'm going to string hash table positional argument. Positional argument map arg to position. Okay. Wait, I have 4 hash tables, but only 2. I need to do another one. Hang on. I didn't init the other way. Short to long. And then parser. What am I doing? Parser. Parser map that's the one, equals the init function. And for now, I should use my dynamic array thing, but for now, just for the sake of not having to look for that, I'm going to say max positional arguments is like 30 or something. If you've got more than 30 positional arguments in your thing, that's pretty crazy. Even, in fact, I'll probably just say 10, because I'm never going to use more than 10. I probably won't use more than 3, to be honest, but anyway. But yeah, I need another, this is where I need the array. It's going to be an array of argument pointers, positional arguments. So this guy maps the string to the position, and this guy maps the position to the actual value of the argument. So that should be the structures that I use. In fact, that could probably be wrapped in a separate struct, to be honest. It probably should be. All 3 of these probably could be wrapped in a separate struct. But for now, I'll leave it. Positional... Parser positional arguments equals malloc size of a single argument multiplied by the max, what did I call it? Max positional args. Okay, whoops. So that's my structures. So, else, if it's a positional argument, then the positional argument is equal to argv at I, and then what? And then the I have to map this. So string hash table add. Am I seriously going to malloc a single integer? I guess so. Int star position equals that, and dereferencing position is equal to the parser num position arguments. Num position yeah, so if it's the very first one, then it should get an add value of 0, so that makes sense. String hash table add, so to the parser positional arguments, that's the hash table, right? Nope, that's wrong. Map the arg to positions, that's the one. I'm going to add a key, which is the argv at I, and then the value is going to be that pointer to position. Fantastic. So we add that to that, and then the idea is parser positional arguments indexed at parser number of positional arguments, which I will increment after I do this, is equal to I just realized I think I did this very wrong. Yeah, this is very wrong. What I'm trying to see, because I need to actually, when I initialize, when I read through everything, when I add an argument, add flag, yeah, so add a flag, I should be doing all this stuff, string hash table add, but in the actual string hash table thing, in the actual adding an argument, a positional argument that is, maybe I'll call it add positional argument, I don't use a structure at all. I'm using parser positional arguments at the index map, num positional arguments plus plus. This is where I do the incrementing. So this array at this index needs to equal this argument. So I might need another number positional arguments int current positional argument, which will also be set to 0. Right? So this tells you the total number, which will be incrementing as they add more and more and more. And then current positional argument is when we're actually passing the given command line arguments, and we're putting them in the right spot. Okay, so Yeah. And I should say something like, so yeah, all this malloc stuff that I was doing over here should actually be up there. Um, so I need to map. I need to map the not the argv, but rather the arg name. Map the arg name to that particular position so that whenever this person using this library requests the value of a particular positional argument, they'll give the name. I map the name to its position, and then I look up in the array, I look up that index. Okay, I think that makes sense. Parser. Yes. So we have the position as a pointer. We get the number of positional arguments because that will tell us the correct index. And then we also use that value again and increment it as well and give the arg thing. Okay, here we go. Parser positional arguments, parser current positional arguments, and we increase that. So this is a different index counter telling us what's been filled in, what hasn't been filled in. Is equal. Sorry, that was dumb of me. And I access the value is equal to argv at I. Argv at I tells us the string version of that value. Maybe I can say something like if parser current position argument is already greater than the parser number of position arguments. I gotta be careful though, because this tells you the total number and this tells you the current index. So it's a bit like the zero index versus the count, which might be a bit weird. Let's say this is 5 and this is pointing at 5. That means I've done 0, 1, 2, 3, 4. That means I've already done 5. So it should be less than or equal to, or greater than or equal to, sorry. So if it's greater than or equal to that, then fprintf it seems we have put too many positional arguments. Exit 1. Otherwise, this should be safe to do. We give this value, blah, blah, blah. Okay. Okay, and then we do that over and over again in this for loop. And then another thing I can do, if parser current position arguments is sort of less than parser num position arguments, after the for loop is done. Once you've done all this and the incrementing, all this incrementing here is complete, I believe this guy should catch up to this guy because they're basically doing the same thing just at different stages. This is doing it to initialize all the arguments or parameters maybe, and this one's to actually give the values. So if it's less than, then fprintf, then it seems we have not enough positional arguments provided or something. We have not provided enough positional arguments. What a chunky function that is, huh? Okay. Let's assume that that's good. Let's assume that we know what's going on. Then argument star get arg parser get given the arg parser, given a key, given an argument name, given an arg name. That should be it, right? And then what? We have to say if, nope, yes, yeah, if arg name at 0 is this guy, then be like, if it's an option, then I think we can just say parser or something like string hash table get parser the main hash table. I need to call this something different though, because HT is wrong. I thought this was going to have everything in it, but that's not true. This is only going to have flags in it. Flag values or something. One, two. Yeah, like this is only for flags. Add flag value, like, and then down here. So from the flag values hash table, give that and give the arg name. And this should give us an argument pointer back. And like if arg, if not arg, then fprintf. This is the arg parser get. It appears argument does not exist. Does not exist. Exits. Exist. Does not exist. Yes. Exit 1. Otherwise, I think we can just return argument. I'm just gonna give the whole argument and then they can figure out what to do. Because I'm giving them type information and everything. Like they can figure out what to do. Else the arg, nope, int star position is equal to int star, I spelt equals wrong, int star string hash table get given the other hash table, given the map the argument to the position, given that guy, and given the key, which is arg name again, we'll get the position, which means the argument is equal to, well, first things, if not position, then same error. Argument is equal to that array parser positional arguments at index position, and then return arg. If else both have the return value, fantastic. Okay, so I think that's pretty much it. Big stretch. Oh my god. Okay. Oh. Is it wrong? Absolutely. Oh, there's errors. I didn't even... I forgot standard error. Once again. Oh, man. So much gas in my knuckles. Okay. I I'll do a quick read through of everything, see if it kind of makes sense. About 250 lines to read, it's not too bad. Okay, archetype, I back, right? It just tells you the type of the information so that, we know what the type should be, even though everything is in strings. I have this thing, I probably won't use it, we'll see, it's fine. In fact, yeah, I'll get rid of it, because I think I'm malloking everything anyway. Putting a lot of stuff on the heap, maybe more than I should, but whatever. Have a bunch of type defs, including the string thing. An argument consists of the value that the argument is taking on as a string, its actual type, what it should be, and whether it's optional. I did not really use this optional thing if I'm thinking about it, but that's fine. I can see how I should use it, but for now I'll just leave it. It's not a big deal. Struct arg parser. This is the main struct. This is the guy saying, this is the guy. Now, I could arguably split this into two structs, or not split it, but rather have two sort of child structs that make up the arg parser, which is struct like the flag parser and the struct positional parser, positional arg parser. Because basically how it's turned out is these three hash tables are in order to parse the flags, right? Flag to values, long to short, long flag to short flag to long flag. These three guys are particularly for parsing and remembering flags. So like I could have put these guys in one struct over here. And then these four fields down here are for positional arguments. Mapping the argument to its position, string to an integer, then making an array of argument pointers, where each index corresponds to a particular argument, a particular value and stuff. So those two are for that, and then the int position args and the int current position arg, number of positional arguments, and the current positional argument. This is for initializing the actual parameters, and this is for giving the actual values for the actual arguments. So yeah, this could be split into two structs, and then, arg parser would in turn contain a flag parser and a positional arg parser. But for now, we should be okay with just having a big chunky boy. All right, initializing, we just got to make sure all the flags get made. So parser is an arg parser, so size of arg parser, good. The flag values, we got to initialize a hash table. Short to long, we should initialize a hash table. Long to short, we should initialize a hash table. Map args to positions is in a hash table. Positional arguments, we're mallocing the size of one argument. No, that's wrong. It's pointers. It's containing pointers. It's argument pointers, so it's just the size of a pointer multiplied by the max things that I said, 10. Cool. And then parser num is this, and this should say equals 0 as well. That's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. Okay, so all the fields have been set, and we return this parser. Fantastic. And then arg parser, add positional argument. Add position arg. Never just call it add position arg. So given the parser, given a name, and given its type, now this is specifically for position arguments, and I will just say something along the lines of, if arg name 0 is equal to that, is a hyphen, then I will just throw another error. Arg name positional argument cannot start with a dash. Okay, fair enough, hopefully. I did change the name of this function actually. There we go. Then yeah, after we're happy, we malloc in arg. We have no value associated with it yet. We have the optional is false because I'm saying positional arguments are always mandatory. Is that fair? I'm not sure. And the type is given by the user who's using the library. The position is malloced as well and is set to the number of positional arguments. To the string hash table, I add I map the arg name to that position that I mallet, and then to positional arguments, I index non-positional arguments and set it equal to this arg, and I increment this afterwards, which makes sense because this will keep an accurate count of how many times I call this function, and also make sure I index correctly, and slot, in each slot, put the corresponding argument. Good. Now, adding a flag instead of adding a positional argument, we have our parser, we have the short option and the long option, we have the type given and the optional. So this is similar, but this time we can also give if it's optional or not. We could also do default. I'm just realizing we could also do default. In fact, I probably should. And that's maybe why positional arguments aren't necessarily compulsory, because maybe you can give a default value. But then how do you keep track of which ones are which? Like for positional. Yeah, I feel like I'm going to keep positional as mandatory. I don't know. Anyway. Yeah. If not short option and not long option, then it's just dead because you haven't actually given a name, which is a problem. So then that's going to, give an error. Otherwise, we can malloc an argument. This is null because we don't know the value yet. Optional is whatever optional is given as, and type is whatever type is given as. If they're both given, then you have to give two-way mappings. So you have to map short option to the long option, and you have to map long option to the short option, so that there's kind of a relation, so that we know that kind of the equivalent relation. Something else to realize, I stood up here because I want all values to be on the heap when using this these string hash table functions, because when I free, I assume the value is on the heap. If short option is legit, then I should string hash table add this argument, which of course is just the address of the argument, which means if I access one of these keys, I should get the same argument twice because it's the same address, I think. So that should be good, like whatever happens to one happens to the other. Wait, does that mean I don't have to do as much work as I thought? If it's the same address. Hang on, yeah, I don't have to do all this work. You know how I do it twice? Like I say, do the long option and then do the short option. I don't think I have to do that because it's the same address, right? I don't think I have to do this, and I don't think... I'll read through it carefully, but just bear that in mind. It's the same address twice when I add a flag. I forgot about that. Okay. Add flag value as a helper. I'll get to that in a second. But void parser pass. So once we've given the template of all the different types of arguments that are possible for a particular program, then we have to call this function in order to pass the argv that some other guy has given when running a program. So for int I equals 1 up to argc, but not including, of course. So going through each command line argument besides I equals 0. If we start with 2 dashes, I've already explained why I think this is safe. I could be wrong, but I think it's safe. We want to make sure it's not just 2 dashes, so we check this quickly, and then we do arg equals add flag value. So we know it's a flag because it started with double dash. Add flag value. If the key, which is the name, basically, maybe I should call it name, like arg name, because that's what it is. I don't know why I called it. Or even flag, actually. Flag is probably best because it's a flag. Is that fine? Okay. So if the flag is given as a null, that's a problem. Return, well, it's not a problem, but it probably shouldn't happen. Return null. Otherwise, we get the argument associated with this particular flag using the flag values hash table. And this flag as the key. If it's null, that means that this key never existed, so we'll just return null for now. Otherwise, if it's of type Boolean, then the value associated with this arg should be straight up true. And bear in mind that because this arg is the same address for both the long version and the short version. Doing this, for example, for the short flag will also do this for the long flag when I do this. Arg dereferenced and getting the value, it's the same arg address that is given to both the short and long option. So if, for example, if the user, I should be careful, if our user who's writing the code and using this library requests to see the short version, the short flag value, but their user gave the long flag option when they were running the program, then I don't think there'll be any conflict or any like mismatch because the address is identical. I think. I could be wrong, but I think that's true. Anyway, so the arg value stood up will be just set to true, right? I just to give it some value. Otherwise it'll just be null and that'll be a problem. Else if it's not a Boolean, else if the index that we're looking at is past or up to the very last argc, then we got a problem because we have no more arguments to take in as a value for this flag. So I say that. Otherwise, argv, the arg value, should be argv index plus 1. So this is basically just an index check, and then we stirred up it as well again because everything should be on the heap. I think. Did I say that? Should this be on the heap as well? I don't really know. Maybe not. Well, I can't do much. I think it has to be on the heap. Oh, well, it is a static variable, so it will last forever. Hang on, where am I? I've lost everything. Yeah, I did say... Okay, maybe I could make this static. I'm not sure. I'll have a look. I'll have a look at all the places I call arg value, and just see what that looks like. I only do it 4 times. Arg is null. Arg value is null. Maybe I can get away with doing everything on the stack rather than using stood up and stood up. Because again, if I deleted it, but if I have static string true literal equals true, like it's a pointer, so then instead of doing stood up true, I forgot the quotes. Maybe I can just do that, and then instead of doing stirred up argv index plus 1, maybe I can just do that. Maybe. Is it risky though? Maybe I'll just keep it like this for now. And then as memory leaks happen, because they will happen, because I'll forget about all this, maybe I'll try to change it back. Okay, anyway. We have all this. So yeah, if it was a double dash, do all that. If the arg was not, if it was null, that means that you tried to give a flag value that didn't exist basically. So then we should throw an error. If it's not Boolean, that means we use the next argument as the value. So I should increment I once, and then it will increment again in the for loop to move on. So we'll skip over that value because I've already used it. Else if it's a single dash, it's a short flag, then if the next guy if it's just the dash by itself, nothing else, then I complain. Otherwise, if the next guy after that is the null terminator, that means I have a single character flag. So I do all this. Same kind of thing. And again, I don't think I have to do this because it's the same address. So I think I should be okay. And then this logic is the same as this logic. Wait, why does this not look the same? Oh, I++ versus ++I. Doesn't really matter right now, but yeah, okay, good. It's nice when they're identical. Otherwise, if it's not just one character, if there's multiple characters in this dash blah blah blah, then for each character in this argvi from 1, not 0 because 0 is the first dash, so starting at 1, going until we hit the null terminator and incrementing along, the particular flag we care about. Should I free this eventually? Maybe, right? because I only really use this in order to, I only really use this heap flag thing in order to find the corresponding argument thing. So I think after I do all this, I think I can say free heap flag. Maybe. If not arg, then if this guy is not recognizable, blah, blah, blah. If the argument type is not Boolean, then again, I think that I just say that's a problem. And once again, I do think that I don't have to do this long version stuff. So all of that stuff was for flags, and then finally else position arguments equals argv. If parser current position argument is greater than or equal to, wait, what? Okay, hang on, I didn't really read that correctly. So else means we got a positional argument because there's no dash dash or anything like that. The positional argument is argvi. If the current positional argument, like if the value, that's an integer thing, if the current position argument is greater than or equal to the number of positional arguments, that indicates that I've already kind of filled out the array, in which case I shouldn't have another positional argument, and so this is kind of dodgy. So we make the claim that there's too many. Otherwise, current positional argument, the array at this index, its value should be argv at I. That is, it should be the what am I talking about? It should be this command line argument, I think. Yeah, and then we do that over and over and over again for all the different arguments until we hit the end of the list. And then we get out and we just have this last little bit that says, if we don't have enough current, if the number of positional arguments given by our user's user is smaller than the number of positional arguments that our user specified, then throw an error. And the last thing is to get an argument given a particular argument name. If it's a flag, then get the flag. And this is where I think the fact that it's the same address is important, because string hash table get, given the particular arg, will find that arg, will return that arg address, and I think that it will be fine. Otherwise, if it's a positional argument because there's no dash in front, then we get the position from the map, make sure that it's legit, and then access the array at that position in order to get the argument, and then return the argument. Okay. Oh no. Okay, we're fine. So I think that kind of worked. I am a little bit afraid that the hash table will break because I don't know if I added things correctly. Like I had a lot of problems with I think the regex engine before about because of my whole double pointer fiasco. There was a bit of a weirdness there, but we'll see. I'll just add double pointers everywhere until something good happens. See, this should be a double pointer, shouldn't it? So this should be like this, I think. Ampersand, 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 ampersand. Okay, so I did it here, I just forgot to do it there. Okay, let's see what happens. So what do I need? clang-i. String hashing? Include? Okay. And then I need all the source stuff from there. And then I need this main. Oh! Did I forget to put the actual... Incompatible integer to pointer conversion. Ah, right. Fair. No, that's fair enough. Can I go to that line? So this should not be, this should be char of size 3. And then hopefully that should be fine, I think, after that. Yes, I forgot to give the actual thing to print. It appears argument this does not exist, which is the arg name. Right, because that's the string. Yup. And then arg name as well over here. Oof, I got an issue here. Static unknown fair. Do it beneath. Again, I don't think I used this yet, but I just want to keep it on hand just in case. Might be a good idea. Did I do this one already? Yeah, I think I did. Okay, so incompatible. Yeah, because that gives the actual character, doesn't it? Okay, I have to be a bit more careful. For char star C, so argv refers to the actual array. I gives you the pointer, and then indexing gives you the okay. So I have to do this +1, I think, will be what pushes it across. So rather than indexing 1, I actually increase the pointer value by 1 byte specifically, because a char is the size of 1 byte. I think that's better. I'm not a huge fan of pointer arithmetic, but I try to do my best with it. Oh, no, that's better, actually. Of course, I can just use the address. I forgot. I can just use the address operator. Good. Okay, let me try that again. Okay. Oh, yeah, wait, I didn't actually do anything. Sorry. Okay, so let's say we have int argc char star argv dash. And in fact, let me be so bold as to say string. So as a human arg parser, I want to make a parser. Oops. Equals init. Right? Doesn't take in anything, just we get our parser. Fantastic. And then I need to give a bunch of arguments. So I have to be like, this is very exciting. Arg parser, add positional argument. So the first positional argument is going to be this is the only thing. I can't give literals, can I? What is the type of a string literal in C? Is it like an array? Like, attempting to modify. Right. So would it actually be better to, every time I want to take in a char name, would it be better to say char array, char arg name array? Purely in the sense that, like, maybe it would let me give string literals kind of thing. I'm not sure if that's how it works, but just because it's annoying to have to make separate variables just so I can get an address, you know? Which I'm assuming is what I'd have to do. Again, like if I have char and an array, char and an array, is that better? All right, you know what? Before I do all this, let me just add this to my GitHub so that if I blow everything up, at least I have something that compiles. Okay. Git add main. Oops. Yes. Git commit -m. Got something that compiles. Probably not correct though. Okay. At least it's there now. Okay. Now let me try this. So if I have, yeah. Because my understanding is if I do it like this, then I can pass in string literals, which would be pretty fantastic. And you know, arrays and pointers kind of a lot of the time get handled interchangeably. So maybe I can get away with what the heck? I didn't mean to do that. Maybe I can get away with doing this. We'll see. Give it a crack. Yup. Looks about right. This, I think I'll keep, because I think that's fine. I'm not really sure. I'm like sort of just guessing. Yeah, that's fine. Yeah, it's mainly the public functions that I want to try and do this so that you can just give a literal if you'd like. All right, let's just see if it compiles or if the type checker has a, okay. So yeah, if I say add arg, given the parser, given the name like, I don't know, wobbly, no, just give a proper name, file name, and the type is string, like that. Okay, so if I compile that, I'm assuming, okay, that's cool. See, and my understanding is though, if I made that string, I think there'd be problems. I could be, maybe I'm wrong. Ah, you can pass in string literals like that. I guess because it just gets read. I guess because yeah, it would be pushed to like that section of memory. I forget where exactly it gets written to, but string literals like is like a static thing, so they just get written somewhere. I forget where, and then I guess that's memory. So okay, so that was maybe just a complete waste of time. So much so that I might I mean, that's why I committed, because I was like, okay, anyway, okay, I guess I misremembered how that works. That's fine. Add position argument, parser, and then I said, what was my other example? I was like, line number or something? Num lines. Okay. And then like add flag. Given the parser, given the short option, dash R, given the long option, given the type, given is it optional or not, I'll say false, but I don't know. And then we'll do a Boolean one as well. Arg parser add flag. Given the parser, given the short option, given the long option, given the type, and given is it optional? It is not optional. Nothing is optional. Everything is mandatory. All right. Let us begin by running that and just see what happens. Whoops. It's not bad. Nothing broke straight away. Yeah, nothing broke straight away. The reason there's this much printing is because I had print statements in here, I think. Yeah, when I was sort of doing some minor debugging. That shouldn't be the reason. Wait, let me just check this. If I comment this out, Not that. Not that. Not that. If I do that and do it again, no printing, right? Okay. Okay, so let me then call arg parser pass. They just called that? Is that what I called it? Okay. Parser given argc given argv. And then let me so argument star arg1. Let me arg parser get given the parser given the argument name. So file name equals -s, which is arg1 value, which I know is a string, right? Yes, okay. And the file pointer is standard output. Is that wrong? Oh, I can't do that because of that. Wait, can I not? Yeah, wait, what? Okay, I'll just put printf actually. I don't know why anyway. Argument arg2 equals arg parser get parser num lines. Yeah, that's it, right? Yeah. And then bing bong. Argument star arg3 equals arg parser get given the parser given, and you have to put -r or something. Printf, I should say, sorry, num lines over here. Printf num no r is equal to %s arg3 value. Argument star arg4 is equal to arg. No, what am I doing? I'm like getting nervous all of a sudden. In this time I try the long thingy, and then okay, here we are. I just realized if it's a Boolean flag and its value is dependent on whether it's present or not, it doesn't really make sense to set the optional thing to false. Like, anyway. So maybe I'll say optional is true, just because I feel like that makes sense. So, yeah, here we are. Wait, what? Oh, I didn't actually compile anything. Okay, so I'm gonna do this, and then I'm gonna do nothing. What happens? It seems we have not provided enough positional arguments. Round of applause, everyone. It did something correct. Okay, good. Let's say I give a positional argument and I say, look, I want my file to be example. Ooh, quotes are going to be a problem, actually. I forgot about that. Okay, there needs to be a helper function to deal with quotes. For now, I'll leave it because I don't really care, but I have to think about that. And then number of lines, my other positional argument, I say is 3. I say -r is, I have no idea what this is meant to be. We'll say A, B, C, D, E, F, G, some string. And then -x is just the flag. It's a Boolean flag, so it requires no extra information. I just punch it through. Oh, what? Wait, oh, the quotes worked. Oh, of course, because argv handles the quotes for me. So maybe I get away with something. What happens if I put like a random quote in the middle? Whoops. Yeah, fair. How intriguing. So the issue with that is you had file name as file name, numlines as numlines, -r as ABC. What happened? I think this became the whole value wrapped in quotes, and then the quotes that were here just sort of disappeared. I don't know. So it's very brittle code. I'm not gonna lie. But it kind of works. That's pretty cool. What else is needed is like stuff like, yeah, handling weird input for sure. Malicious input technically probably would break this very quickly. Or just, people who misunderstand how to use it. Passing functions I think would be really helpful. Like for example, like passing strings to integers, passing strings to floats, passing strings to booleans, etc. and doubles, because the fact is, right now, everything's a string. So you're not actually going to be like this 3. Cool, I can print the 3, but I can't actually, how do I say, work with the 3 like numerically. Like if I try to add 3 to 5, I'm not going to get 8. I'll get an error. It'll be like, I can't add a string. What happens if I put too many positional arguments? Oh. Wait, what? Oh, it's because of the quote stuff again. Hang on. Let's just pretend that quote stuff doesn't happen, yeah? I'm not sure how exactly it's meant to be handled, but nice. Good stuff. Okay. This was not a complete waste of time. Thank goodness. I was nervous because I thought the string hashing would blow up, because I didn't really test that as well as I should have, but it seems like it's going okay. Which is good. We can definitely clean up code, like structurally. This is like the idea here, I think, is good. Although it would mean I have to sort of reach into a few extra structs, like one extra layer of structs before I can access my fields. But I just feel like organization wise, it would be good. But anyway. Yeah, there's definitely nice little structural things you could do. But as a one shot attempt, I started at what? 10 o'clock, 11 o'clock? Roughly? Yeah, like around 10. It's not bad. It's been like 3 hours. I don't even know what else to do. I guess because the resizing happens when there are 6 things in the hash table, so maybe resizing is what will break it. So for example, let's say I have 7 positional arguments, right? Of course, the other thing is I have to do freeing memory management, which would probably destroy it. I'll just say A, B, C, D. Just can't be bothered anymore. And then I'll just say like float, double. Boolean is kind of a weird thing to have for a positional argument, but whatever. Float, double, Boolean. Yeah, then int is fine. That's fine. Okay, and then maybe I can have a helper. Just void print argument value. This is more for debugging than any actual usage. But given kind of an argument, and given the parser as well, arg parser, parser. I basically just run this. I say argument star arg is equal to arg parser get Parser. Well done. Given the parser and given the argument, and then just print this basically. Arg. Nope. Oh, I gotta be careful actually. Arg name. arg name, arg value. Okay. That way I don't have to write the same two lines over and over again. I can just be like, print arg value given the parser and file name. I spelled file name with a colon. And then lines A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so there's like enough. There should be enough of these guys to cause a resize, which is usually where the breakages happened, at least last time. Let me compile again. Wait, why didn't it break? Wait, what? Did I call the parsing function? No, I did not. Arg parser pass. There you go. And then now we'll have like A3, I'll just say example.txt. 3, 1.2, 2.4, we'll say true or something, I don't know. And then 10, 11, 12, 13, 14? I messed it up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, four integers at the end, a boolean, double, float, integer, yeah. Okay, I mean, I'm pretty sure resizing would have happened. We can confirm that. Just roughly speaking. I'm sure there are bugs somewhere. It's just, yeah, I mean, yeah, no, that makes sense. I'm sure there are bugs somewhere. I just don't know where. I guess, as I use this library, and I will be using it for some stuff, just for lols. As I use it, we will find them. Anyway, that's my very, very scrappy arg parser. I'll probably augment it with some parsing functions like converting a string to integers and string to floats and stuff. But yeah, as of right now, that's my arg parser. Fantastic.